Hey, what's going on, guys? CMK here. It's been a while since the very last video has been released on this CMK channel, and since then already 1K of subscribers has arrived to CMK channel, which is a really good news and something that I can celebrate today, basically. So I didn't make videos here on CMK channel, but the reason for that was because I was developing my chess programming channel, and at the moment, just to give you an idea, so I already have 96 subscribers on my chess programming channel, and I know, guys, that you don't really care about this, and I'm not forcing you to subscribe to this channel like I did before, obviously. Just want to show you what I have been doing since just want to show you what I have been doing since the very last video on CMK channel. So currently here are kind of 4 playlists, and I've made 89 videos on completely new chess engine in C. It's not the one that I've been showing you previously, not this one, but absolutely new engine that is playing for about 2,000 points of elo strengths. That's the measure of how to that's the way of how to measure the strength of the chess engine, but it's not the case really. So the reason why I'm talking about this sort of stuff today is quite a bit. It's might be quite a bit surprising. So I've been trying to avoid machine learning at any cost in my life and in my career, basically, but it happens that in order to make a decent evaluation function in a chess engine, quite often it involves some machine learning technique, like let's say now in particular I'm learning and trying to make my very first machine learning project that regards to logistic regression, which is the classification problem, and the idea is to the very first couple of ideas I have is to calculate the values for chess pieces and the values for p-square tables that scores pieces positionally, like say pawn on d4 has more positional advantage than pawn on a6, things like that. So usually people can simply just handcraft those values for all the pieces, like for opening and for the endgame, and then interpolate those values back and forth. But using machine learning, in theory, we can obtain even a better values compared to those that are handcrafted. So that's the entry point where I didn't really want to go into that machine learning, but it seems like I really have to do that. And I just want to share some particular atmosphere that I'm currently living in, and after that maybe share a little bit more thoughts on the future of this CMK channel as well. So I've been surfing the internet and eventually found this blog post by Erasmus Bath, I believe. So unfortunately, he's mostly coding in R programming language, which I really hate, and I didn't even have to install this R Studio to be able to run the code, also the R language and some packages as well. So the idea of this project is actually take the PGN file. So to give you an idea of what the PGN file is, so this is just the text file that contains the chess game notation, like e4, e5, knight f3, knight c6. So these are literally the chess moves, and also every game has results, like is this a win or a lose, or win, lose, or a draw. Well, obviously we need to omit draws because logistic regression assumes only the binary predictions, so draws are not ever taken into account. But the idea is, well, the very first exercise I'm now working on is to predict the weights of the piece values. So if I have a look at the blog post, here we have the values, like whatever chess book for beginners would tell you that, say, knight is worth of 3 pawns, like bishop is also worth of 3 pawns, like rook is worth of 5 pawns, queen 9 pawns, and that's kind of it. But if you just have this fixed values without that, if you don't have these values that precise, then it might affect the playing strength of your chess engine negatively. So just to bear that in mind. So the more precise value for pieces you have, the more stronger your engine would be playing. And also bearing in mind that these values can interact with the positional piece table values as well. So just to give you a little idea of what those tables are, just let me open the source code of my engine, and I will now show you that. So my engine is completely written in C, not in Python, obviously, because it's just faster. But here I have, well, these values are not mine. I've grabbed them from a guy named Ronald Frederick, who is a chess engine developer. So here we have the values for white pieces and for black pieces in the opening, and here the same for the values, but in the end game. So say pawns starting getting more valuable in end game, while queen is not really that valuable in end game as it is in the opening. So these values are different, and we have 3 game phases, like opening, middle game, and end game. And if we have a pure opening or pure end game, which is calculated based on the availability of the material on the chessboard, in that case, we use this pure scores. And for the middle game, we need to interpolate the values between this two, both for material and for positional tables. So here are the tables for pieces, like what kind of score in so-called centipawns your position will get. And eventually like your evaluation static evaluation function will return. So these pieces are generally just given the idea of just given an idea to your chess engine of where to develop its pieces. That's kind of it. But again, the particular values of these tables matter so much. So just to give you an idea, my previous implementation had a handcrafted version of these tables, and I only had one set for all the game stages, and the engine using those handcrafted tables was playing for about 200 elo points weaker compared to my current version, which is really significant numbers. So like it's incredibly significant number to be honest. So that's kind of it. And my current machine learning task is actually to calculate these values from scratch, basing on the PGN files containing really lots of chess games played, well, most likely played by chess engines to get more precise values, because chess engines are stronger than human players. So that's kind of the idea. And you know, like as far as I get my very first, I got my very first real-world task in machine learning that I'm incredibly interested in, because it's the matter of the strength of my chess engine, which is really important to me. I'm really tempted to get my hands dirty with this machine learning stuff and try and eventually implement this. So what am I currently doing is I'm processing the PGN file, I'm parsing this headers, and then converting every single game to so-called FEN strings. So if I just show you how the eventual data set looks like, this is what we'll have. And if we have a look at this games.json, so we have this headers being parsed into JSON format, and instead of having the moves, we're actually using this encoded version of the position. So it's quite pretty simple. It's just like a chessboard, so ranks from 8, 7, 6, 5, 4, 3, 2, 1, and these uppercase letters are white pieces, lowercase are black pieces, and digits a number of empty squares. So we have digits like this. It means like 3 empty squares, then white pawn, then 4 empty squares, and so on. So here we have all empty squares, which means that the rank is completely empty, and so on. So this is the way of how to encode the chess position. And based on this, would be counted material later on, like how many pawns, bishops, knights, and so on is available on the board. And based on those numbers, and at the same time based on the results of the game, would be predicting the values for the pieces. So eventually at the very end we'll try to get some sort of this relative numbers to represent the values of chess pieces. So obviously this is the very basic steps to consider, but without these basics nothing really would happen further on, because everything is based without basics you're not gonna go in anywhere. So at the moment I have a code that does this, but the Python stuff. So I had this Python code, or hold on a sec, which one? No, this is not my code. This is the code by the guy who has written this article. I just commented this code a little bit, and here I've rewritten this in a more cleaner fashion to make it more human readable and clear, like I always do. But unfortunately, these 3 R files actually. So this one prepares the data set. This one, what this does, calculates statistics and fits the model and so on. And the very third one is doing. Oh my God, what is this doing? Well, not sure really. So I still need to dive into this to get it more clear. Obviously, I would be doing all this stuff in bare Python using the scikit-learn library. But anyway, I'm forced basically to dive into this R code, which I have no idea like what the hell is going on here. But still, just because I'm really tempted to solve this task and actually to get those values from my chess engine, both for piece values and for positional square tables, and then try to just make my engine stronger. So that's kind of the idea. And quite pretty interesting thing here, that exactly the process of getting hands dirty with machine learning is actually something that I couldn't experience in the past, because when I was trying just to pick up some tutorials in machine learning, just providing some sample data sets, that data didn't make sense to me at all. And when data doesn't make sense to you at all, it's incredibly hard to learn machine learning, and it's incredibly hard to actually master it, because you don't have the motivation. You just think like, why do I need this data set? I don't care about this. That's kind of it. But when you really do care about the data sets, and when you exactly understand what kind of values you need to predict at the very end, and how and what particular impact those values would make on the strength of your chess engine, that starts making perfect sense to me. So that's something I'm currently working on. And obviously this initial machine learning tutorials related to chess programming will be released on my chess programming channel. But I just thought that if that goes well, maybe I will start making some machine learning tutorials on this CodeMonkey King's channel. And here we're coming to a very interesting pivot point. So assuming that I already have exactly 1,000 subscribers on CodeMonkey King's channel, today I've just applied to YouTube monetization and this partner program, just trying to make some videos, just trying to make some money from my videos using the advertisements. Because I don't know, like I think that before I didn't want doing this, but now I'm spending too many time on chess programming, so my income is not that great as it was when I didn't do this, because like chess programming takes really lots of time. So I really want to make some side income using this YouTube channel, which I think this is quite pretty fair. So I hope my channel will get improved and all this stuff. But the problem that assuming that like web scraping might be so there might be really lots of issues with web scraping, like violating the copyrights, violating the policies of how to use the particular website. Like an example, if the website doesn't really allow you to scrape it and you're doing this, and if the owner of the website would see my video and say like, okay, so this guy is violating the rules, then YouTube can just simply delete my account, believe it or not. And that's quite pretty bad scenario, to be honest. So what I can say that at very least at this moment I said everything I could about web scraping, and I literally have nothing else to say about the web scraping, believe it or not. But I think that starting machine learning era on this CodeMonkey King channel might be a good idea. So I will first try to train on my chess related stuff, and if that goes well, then probably I would start releasing some new tutorials here on CMK's channel related to machine learning. And again, like, assuming the channel that supports the YouTube partner program and monetization, I believe that machine learning problems being covered in the format of videos are more likely fit in the policies of usage, the YouTube service in general. So I mean, like, when you don't make money on your videos, nobody really cares about like what kind of sites you're scraping. But if you start doing that, I think that this is possible, that for some reason somebody might get frustrated with that his site is getting scraped by CodeMonkey, so that might not end really that good for me. So, like, the idea of this channel is good, and there are new things to cover, basically, because I'm kind of developing myself every day, and I really have lots of things to express and to share with you guys. So this is kind of the idea at this moment in particular. So this is what I wanted to share with you guys, basically. So if everything is going fine with my very initial machine learning task, in that case, probably, well, not that it just flying around my camera, sorry guys. So maybe not just that often to produce videos like it was kind of 2 or 3 videos a day like it was this spring, but probably maybe one video per week, maybe two videos per week, because I mean, really, I'm kind of like really involved into this, my new chess programming channel, and assuming that chess programming actually is some sort of a topic that can actually violate some copyrights because it's all free. So that's the perfect format for me as a YouTuber to actually go on. Okay, I'm sorry guys. That's the perfect format for me, because I think that monetizing this chess programming channel would be more appropriate and less risks compared to this controversial content that is available on CMK's channel. So I hope you understand, guys. But anyway, I think that if we just go to machine learning, in this case, these old videos won't really make that great impact, or if something would go wrong, I would be able just to delete some of them, if any copyright claims and things like that. But the overall content won't really suffer from that. So that's kind of my thoughts regarding the future of CodeMonkey's channel, and I'm really tempted to know what do you guys think about this, and especially some new subscribers, because I think like really lots of guys have subscribed since a month ago, basically. So I didn't yet chat with you because I'm always trying to be in contact with all my subscribers, in more or less, but I'm just trying to always answer the commentaries and things like that. So guys, please let me know what do you think about my machine learning tries in the commentary section below this video, and hope that one day some new videos on this topic would arrive, basically. So this is it from my side. Thanks for watching, thanks for subscribing, and hope to see you one day. Okay guys, so have a good time and take care.